Hi, welcome to this video of OpenFOAM. I'm going to talk about templates today. So we spent the last video actually tidying up the sandbox 2 code so that we can have ourselves enough space to do a template demo demonstration. Okay, a template demo demonstration. Okay, so let me go to the sandbox folder. And the nice thing about, I think, this particular laptop, it's running KDE. You can actually just do this in one terminal. You can split left and right. It's very convenient. Behaves a bit like a tiling window manager. Anyway, so yeah, here we are in the demonstrations folder, and I can go to the sandbox2.c, and this is what we did previously. Okay, so there's a time function demo.h file, which we were tidying up everything. Now, next thing I want to include is this template demo.h. Okay, so okay, again, with OpenFOAM, there's a coding style guide, which I kind of want to follow as closely as possible. OpenFOAM coding style guide. Okay, so you come here. Now you will be able to see all of these things here. Remember, 80 character lines max. Normal indentation is 4 spaces per logical level, and do not use tabs. Okay, avoid trailing white space as well. Okay, so now I'm going to use 4 spaces. I'm going to include the template demo.h. Okay, so this will be the driver file. As you can see here, most of this will be blocked out. I can go to the template demo.h. Oh, I think one more thing. I almost forgot that if you want to define new functions and classes, you should have to do it before the driver file starts. Okay, always put it here. If not, yeah, you want to declare classes and functions before the whole thing starts. So let's go to template demo.h. Okay, so this is what a template looks like. If you go to the Geeks, Geeks for Geeks. Okay, Geeks for Geeks, what do you call it? Templates, C++. Yeah, templates in C++, it's over here. Okay, it's a simple yet very powerful tool in C++. And here's they have all the stuff here, which I'm basing my what do you call that? I'm basing my tutorial or discussion of this website. Okay, so this is the syntax of a template. Okay, you will type template. Okay, open pointy bracket and close pointy bracket. Okay, you can put class or type name here. Then you put type. Okay, and wherever you have this type, you will you can actually put it here. Now, how does all this work? Okay, so this is what one example, but let me comment all of this out first. Now, let's say for example, okay, before I go to this, let's have 2 functions, okay, and both of them, what I want to do is to return a number. Okay, return a number, which is to basically print a number out, and yeah, return it as, I mean, the function's job is to return a value or number. So these are some functions I want. So for example, if I want to return a float, right? If I want to return a float, okay, so what I'll do is this. Let me define a float here. Float a equals 2.23, right? Float a equals 2.23 here. Then what I can do, this function will be declared in template demo.h. Okay, so I can just use the function straight away. Okay, so return number. Okay, and I'll put a. And that's just calling the function. Okay, now I'm going to exit, and this is a very simple code. It should not have errors, but you know, coding is such. you might have errors. Okay, so if I go and open Sandbox 2, you will see this line A is 2.23. Why? Okay, so all this function does is to take the float variable that you give it and print it out. Okay, return the number. So this info uses a foam namespace and it says A is so and so. Okay, so this is the variable A, which you gave in as 2.23, and then it will just print this out, and of course it will return A. Okay, so meaning to say, if you go to sandbox2.c, if I say float b equals to return number.a, and I can actually get the value of b here. That's very basic stuff. So info, okay, b is then you can return the value of b and end line. Okay, and w make this. Okay, so this function will be called twice. Oops, sandbox2. So you see, a is 2.23, b is 2.23 because I returned the value here. This is just a function. Now, what happens if let's say I want to make this function compatible with an integer? Okay, what I have to do is to completely code a new function. Okay, completely code a new function. So yeah, let's say I try to do this integer. The function will return the type integer. It will take in an integer a, and it will just say a is blah blah blah. A is something, and then it will return a. Okay, so now what happens? Okay, well, if we compile it as is, the compiler will complain because you're defining two very similar functions. One is called return number, the other is called return number. Okay, okay, if you do sandbox2, this will still be okay. Let's try sandbox2.c and let's put an integer in here. Integer d equals 5.67. Integer e equals to return number d. Now, let's see whether this code works, or will the compiler give us some problem. Okay, you'll see a problem. It says int character is in the function int main blah blah blah. Okay, it says that there's an unused variable e. Okay, I mean that's fine. Okay, there's an unused variable e dot here. Then what we can do is, I mean, it's not that serious a problem. You can just say e is something like that, end line. Okay, wmake. Okay, so no problems there. So you have two kinds of functions here. One is a integer return number, one's a float return number. Okay, that's well and good. Okay, you have two exactly, well, almost exactly the same functions, except they use different data types. So it looks like C++ will, or at least the compiler will know how to differentiate them based on the inputs, all right? Because what do you call that? For example, if you say, let's say float, you define a variable called float a, okay, and you're giving return number a float variable, and you expect a float variable to be returned. So C++, the compiler will know to look, okay, I'm looking for a float variable, giving in a float variable and taking out a float variable. Okay, likewise, if I give in an integer variable d and I request an integer variable e to be returned, then the compiler will know to look for this function. Now, let's say I want to have many of such functions. I want this function to work for character, I want it to work for string, I want it to work for double. So do I then go and code like, 10 functions or 5 or 10 functions depending on the data type? Well, the thing is that you don't need to do that. And that's where the usefulness of the template comes in. Now, you see this thing, whether it's integer a, float a, or double a, you can do many things here. So let me copy and paste here. We can change the type to character, which is it will give you a text, okay? Or you can also put double. You can have a double here. Okay, so you have a double here. Okay, so if I want one function for integer, one function for float, one function for character, one function for double, see how many lines of code this actually takes out. It's about 25 lines of code. Now, if I want to shorten shorten the line of code and make life easier for myself, I can just do this. Okay. Well, technically, character is not a return of a number, by the way. But anyway, I digress. So how can I do myself a favor? How can we do ourselves a favor? By saving some lines of code, because this is the same function, pretty much the same function, just working with different data types, right? Different data types. So to make life easier for myself, we use something called template. You notice that the functions, they only differ by the data type that goes in, whether it's integer, float, character, or double. So won't it be convenient if we can make a way for ourselves to how do you say, have one function, and you can also specify the data type that is going in and out of this function. All right, so you can do that. The way you do it is basically you copy and paste. You can copy and paste the way you normally code a function. All right, and you replace int here with type. Okay, or any kind of string variable. Okay, you can replace the int with type, the float with type, and whatever. And all the only lines you have to insert are template class type. Okay, and this is the basic way you can design your template. Okay, so I repeat again. Okay, so if you want to make a new template, and you want to make a template for this kind of function of different class type, all you have to do is type template class, and then you can put type over here. You don't have to use the word type, but OpenFOAM likes to use the word type. If you take a look at the example here, you can actually replace it with any string variable, x, y, z, anything you want. But in the OpenFOAM way of doing things, they like to use the word type with a capital T. So I will stick to that convention. Okay, so you can use type over here and type over here. And this is your template. This is a templated function. So when you call the function, not only do you have to give in A, you also have to specify what kind of data type A is. Okay, whether it's an integer, float, character, or double, whatever you want. Okay, so this is the basic way of having a template. Okay, so you can see that what I made here is very similar to what I already have here in my demo file. The only thing is that this extra line is inserted. So, just for demonstration purpose, let me comment out this line first so that you can see how template files are typically called and run. So, to call a templated function, okay, it's very simple. How do you call a template function? All right. So if you take a look at here, here's nothing. We are just declaring a float variable a equals 2.23, and we are declaring a float variable b, and we want to say the b is the output of this function called return number, and return number is now this templated function. Okay, and where do we then insert the what do you call that? Where do we then insert the templated where do we then specify the data type? Okay, so you see this these two normal brackets. You just put these two pointy brackets there. I like to call them pointy brackets. Okay, and then you just insert the data type. Okay, so this is how you call the function, and it will be exactly the same as, you know, how do you say? Yeah, it'll be exactly the same as this, calling this function over here, the float return number. So everywhere you see float, okay, it will substitute into the type over here and the type over here. Okay, so yeah, everywhere you see float, okay, it is where this template will substitute whatever you type here. So this is the word type with a capital T, and everywhere you see type in this function, it will be replaced by whatever this thing float, whatever the whatever data type you have given it. Okay, so actually somewhat of a less ambiguous name. You can use this thing called type name here to to put it here. Okay, so we say this type variable is of the class. It's a variable which is a type name kind of variable. Okay, and the other way to define this type variable is to use class. Now, just to clarify, this class is not the same class as, you know, we normally declare in class declarations for object-oriented programming. It's completely different. Okay, or at least practically speaking, it's mostly different. So just be mindful of that. If I had my way, I would use the word type name here, but OpenFOAM style likes to use the class. So let me show you. If I go to source and go to finite volume, and let's go to FV matrices. Okay, and let's go to FV matrix. So this is where we found our many codes, many lines of codes. You will see the template and everything here. Class type, blah blah blah, TMP. This one I won't explain yet, but you can see a lot of templated class. But you can see that the data type, okay, remember everywhere you see type here, you can substitute with an integer, float, or whatever kind of data type. And that includes scalars and whatever. These are OpenFOAM specific types, or depending on whatever C++ program you have, but this is pertaining to OpenFOAM. So yeah, you can see type over here. Type is just here to say, all right, I want to substitute everywhere I see type with this, everywhere I see type in this template, I can replace it with whatever data type I want. So it pretty much behaves like a function. So without further ado, let me do this one. Let me edit this and also edit this. Okay, and all this does is to help us to, what do you call it? Help us to call the templated functions, and it will run exactly the same way as what we have just now. But we just saved ourselves many lines of code, many lines of unnecessary code, because we use a template. So that's the main function of a template, is to help us save lines of code. And not only that, if I suddenly now want to, hey, sandbox2.c, if I, let's say, want to return a scalar or vector, for example, okay, So let's try playing with the scalar class. Scalar, scalar1. Okay, scalar1. So scalar1 is a variable of the type scalar. So I want to say scalar1 equals to 10.2, and let me do a scalar2. Okay, scalar2. So scalar2 is of the type scalar. Okay, and let me do return number. Okay, and I want the type. I want the data type now to be scalar. Okay, and what do I put in? I put in scalar1 here, and that will just return 10.2. Okay, let's do wmake. Oh, yeah, it says scalar2 is unused, which means I can just solve this. I can just print this out. So this is the OpenFOAM specific one. Info scalar2. Scalar is, yeah, I can say scalar value is, and I'll just have scalar2 at the back. Okay. And line. Okay, wmake. And let's do sandbox 2 and see the 10.2 is given. So I can use it for any data type, not just the standard C++ type. As long as you have the data type somewhere declared somewhere, then you can use this, no problem. Okay. Now let's go on. Okay, what is this type ID name? Well, I can of course show you all of these functions, right? I can of course show you all of these functions, and I just return you a random set of numbers, right? If I put in 2.23 and I put this into the return number function, and then I can return 2.23, right? How then do I know which kind of what kind of data type this function for example A is? Okay, if you have an integer, if A is an integer, how do you know A is an integer? How can you check? Okay, the way to do it is to use type ID. So let me look for type ID. Okay, name. This is the function that I use. Okay, no, not this one. Okay, maybe I can use type name. Okay. You run this. Okay, so okay, you take a look at this here. When you use the type ID and you use the function name, so type ID is a sort of a class or something like that. Okay, you give this class the data type or the piece of data. For example, we just declared A to be of type. It could be integer, it could be float, whatever. Okay, so we print out A is something, and I want the data type. So I use the type ID function, and I use the type ID class or something like that, and I use the name function. Okay, I'm not sure if type ID is strictly speaking a class, but the syntax does look like a class. So how do I know I'm really having different data types? I use the type ID operator. I think maybe it's called operator. You don't call it a class. Okay, so if all things go well, I should see the data type is what? Okay, the first data type is a float, the second data type is an integer, the third data type is a scalar. Okay, so let me save this and let's see, let's wmake again, and let's check whether this thing actually works. Okay, sandbox2. Okay, so the first data type is of type float. Okay, so A is 2.23, A is a float data type. Okay, so it's a float data type. The second one is we just return an integer. We put an integer into this templated class, and then we have a data type of I. So I actually stands for integer. Now the third one is quite interesting. You actually have a scalar data type, right? A scalar data type. The scalar data type, they return D. What is D actually? Okay, D is actually a double data type. So you can tell scalar actually is probably a subset of the double number kind of data type. Okay, so we can see that it not only works for the standard C++ data types, but also the subsets of these classes. For example, scalar, which is quite an OpenFOAM type of class. So this type ID doesn't return every single custom data type that you define, but it shows you the underlying data type that is associated with, for example, scalar, which is a double in this case. Okay, so yeah, enough yapping. I think that's almost half an hour. So hopefully this video has shown you what a template is, what's the usefulness of a template, and how to call it. Okay, so I'll see you again. Goodbye.